Though there are hundreds, dare I say thousands, of graphs available for illustrating data, I want to introduce just one more graph to conclude our Examining Distributions series. That graph is the time plot. Time plots are created with quantitative variables. We use time plots with variables for which we are most interested in change over time. With time plots, we can identify trends such as an increase or a decrease in the variable value over time. For example, we might wish to study the increase in reading ability of a student across 5 years of elementary school. As another example, we might look at the change in weight across the weeks of a diet. We could study the reduction in bacterial levels in response to the number of days on an antibiotic. What is common about all three of these examples is that the researcher's primary interest is in seeing how the variable changes over time. Note that the unit of measurement for time can be years, weeks, days, minutes, or any unit of time. The unit we choose is based on context. The key point is that as time goes by, we anticipate change in some variable, and we want to study that change. Here's what a time plot looks like. Notice that time is on the horizontal or x-axis. The variable of interest is on the vertical or y-axis. In this case, the variable of interest is the winning time in the Boston Marathon, given in minutes. We want to look at these winning times over years because the Boston Marathon occurs just once every year. Note the trend in these data. There are plenty of faster and slower times from year to year, creating peaks and valleys in our plot. But the general trend as we move across the years, that is from left to right, is a decrease in the winning time, meaning that the runners are getting faster. That is until about 1980, after which the speed levels off. The time plot helps us quickly see this trend. Let me show you how I created this plot using R. First, I read the data into an object that I named bos.mar, which of course is my shorthand for Boston Marathon. This object has two variables, year and winning time, given in minutes. I created the time plot using the plot command. The first argument is the year, and the second argument is the variable of interest. In this case, the winning time in the marathon. The third argument is type equals L. The L here stands for line. So this is telling R to connect the dots with a line. If I didn't put in this argument, we would see a bunch of dots on this plot rather than a nice line that illustrates trend. After that, I labeled the X and Y axes, and then I gave the plot a title. When I run this command, we get the time plot for the Boston Marathon that we just saw. Time plots provide a useful way to look for trends across time for a variable that we anticipate will change over time.